So what we have here is a candle, and it's just a regular old candle that you stick in your window at Christmas time, and it sends out light in all directions. And so you can see some of the light is hitting the cardboard over here, and if I were to block the light, you can see where it hits there. So some of the light is hitting the cardboard. The light is spreading out in all directions. But what I want to do is I want to stick a lens in here. And if I stick a lens in here, then some of the light, which was spreading out, so as the light comes here and spreads out, some of it gets bent, and you can kind of see a bright spot there. Now, here's where it gets really cool. If I move this to a certain location, then an image will form. So what I mean is this. If we take a really close look over here, you can see that what we actually have on the cardboard is a little tiny light. It looks just like the candle that we started with, except it's over here and it's upside down. And so if I really make tiny adjustments here, I can make the light converge right at the right place, and we call this focusing. So if I get this, let's see, that's worse. So it looks like right about there is focused. You can see a little tiny bulb. Now here's the really cool thing. So what's happening is the light, which was spreading out from the bulb, it was spreading out in all directions. It got bent by the lens here and focused back to a single point there. So you can see an image of the little light bulb, okay? So we call the distance from the candle to the lens, we call that the distance to the object, and we call the distance from the lens to the image, we call that the distance to the image. And we're gonna do a lab investigating that. But let me just show you what happens. There's actually two ways to form an image. If I move this lens closer to the light, then something cool happens. Over there, you can perhaps see an image of the light. So now here's the original light, and it's kind of bright, it's hard to see, but it's actually got a little piece of wire that's glowing hot. And that light is spreading out in all directions, but the part of the light that hits the lens here gets bent into an image, and in this case, the image is bigger than the original object. So the distance to the image is from the light to the lens, that's the distance to the object, excuse me, and the distance to the image is from the lens all the way down here to where that image forms. And if I move my lens a little bit, you'll see that gets out of focus. There's only one spot where everything's getting bent in just the right amount. Now that's out of focus. And so we say we are focusing, and this is exactly how an overhead projector works. It's how your eyeball works. It's how a camera works. We bend light using refraction to form an image. In this case, the image is magnified. It is larger than the original candle. So there's the candle, and there's the image of the candle being projected over on the cardboard.